In this session, we want to look at using our circuit simulator to build more complex black boxes. So I'm going to come over here to our simulator, Subcircuit. And the first thing I want to do is, remember we tested out our AND functionality, so I'm going to grab that terminal, that output terminal, move it over a little bit, select the line, the wire connecting them, and delete that. Then I will come over and get a NOT gate and put it right in between there. I'll then connect the output of the AND to the input of that NOT, the output of that NOT to my terminal, my output terminal, and now we can see that it functions as a NAND. In other words, the only time I get a 0 or other symbol out is when both of the inputs are preferred. And you're like, wait a minute, that's not exactly the way you phrased it before. There's different ways we can look at the logic, so this is where truth tables come in handy. So I'm going to come back to diagrams.net and invoke the snipping tool. That's Windows Shift S. Select that NAND. And when I get a notification here, I'll click on that. That opens up the snipping tool proper so that I can save it. And it's going to, by default, save it into my pictures. I'm going to call this NAND TT for truth table. And save that. You might figure out an easier way to do this, but at the moment, Subcircuit doesn't really support drag and drop that I know of. Okay, at any rate, now I can close that, and I can come back to Subcircuit. And what I can do is come down to annotations and add an image annotation. Okay. Now I can double click on that, grab that image that I just saved, open it up, and there is my truth table. Now, it's a little squashed, and if you're like me, my OCD is kicking in. I'm like, that's a little bit too squashed vertically on that. So you can, under properties, with it selected, they have rows and columns. So I'm going to increase the rows to increase the vertical distance a little bit. Okay, that looks better. I feel better now. And there we have it. Now we can see that, okay, the only time I get a other out of it is when both of the inputs are preferreds and ones are preferreds, and yeah, it takes some getting used to, but you will, trust me on that. Okay, great. So now the next thing I should probably look at is perhaps the fact that Subcircuit does not save automatically. And so if I come up to the project menu, we have the options to save online or offline. So we created that account so that we could save them online. I'm going to do that. It makes sharing them easier. I'll be able to see yours if you share it with me easily, and so on. Okay, so that's saving. Don't forget to save when you make changes. Keep in mind that if you close your browser, the changes are gone. If your browser closes itself, they're gone. So save frequently. On that, the next thing I want to do then is, I notice up here there's a tab there and a plus sign, so I can create a lot of tabs. And right now it says main. Well, that represents the circuit that I'm working on. So under properties, we see here's the circuit main, and I can change the name of that to something more meaningful like NAND. Notice as I'm doing that, the name on the tab is changing here. And okay, all is good with that. Now what I can do is I can use any tab that I have here, any circuit that I have, as a subcircuit. So what I'm going to do is I'm going to click on the plus sign, and it says, oh, what do you want to call the new circuit? And I'm going to call it NAND-orama, because I just want to play around and insert a few subcircuits to see what's going to happen. So now I can either come to the circuit menu and say insert subcircuit, or I can right click someplace and in the context menu say insert a subcircuit. What I'll see is a list of all those tabs up here of circuits that I can insert. So I'll select my NAND since it's the only one I have at the moment, and I'll say insert that subcircuit, and there it is. Shows up as a black box. I can insert again. I can also Control C and Control V and paste them wherever my cursor happens to be, wherever my mouse pointer happens to be, I guess I should say. And then I can connect these things together in any combination I want. I can grab a couple of inputs like we did before. And I'm going to say Control C, Control V, paste that one over there. Maybe connect those two to the inputs there. Maybe grab another one, connect that into this other unused input. And finally, I'll grab an output and connect that there. And then we can say, oh, okay, what are the results of this circuit? What inputs produce what outputs, and we could build a truth table for it. I'm not going to right now because later on we're going to want to talk about what happens when we connect multiple ANDs together versus multiple NANDs versus multiple ORs and so on. But for the moment, I'm satisfied saying that we can now create and use subcircuits. Again, we can give things labels as well as we should. You'll notice that, by the way, the labels that appeared in the black box were the labels that were used in the original circuit. Okay, so whatever I called these, when I call these A, B, and C, that was what was used in the subcircuit, and that's why they're important. In fact, I can also, I'm back in my NAND now, I can edit the layout of this, and I can move these around to wherever is convenient. They're pretty good there, but I can do that, and then if you make changes, save those to the layout of that. Save that layout there. Okay. And then there's our NAND-orama. Yeah, good.